Okay, so as you can tell, I'm going to be going through the radical test review, and I'm just going to go really quickly through every single problem that deals with radicals. I'm not going to go through the extra review at the end. Let's just start at number 1 and start going. Number 1, it's the square root of 16. Well, if you've written all the perfect squares at the top of your page, you will see that 16 is a perfect square. So I can actually just go right away by saying that this is going to equal 4. The square root of 16 is 4. Let's move on. Number 2, we've got 72. If I'm trying to take the square root of 72, I'll realize that that's not a perfect square. But we can split it up into two other radicals. For example, 9 and 8 would be two radicals that would go into 72. 9 times 8 is 72, and 9 is a perfect square. Now that looks good at the start, but I'm also noticing that this isn't probably the biggest square. Now I can tell that it's not the biggest square because I know that 8 has to be simplified more even, because 8 could be split up into the square root of 4 and the square root of 2. So if you ever try to split this up like this and you realize, well, it's not completely done, like 8's, you can take a perfect square out of 8. What I encourage you to do is just kind of start over and try to find a bigger perfect square. So if 9's not the biggest perfect square, what is? Well, I think 36 would go in. So the square root of 36 and the square root of 2, those should multiply to get me 72. The square root of 36 is 6, and the square root of 2 is just going to have to kind of hang out with it. We can't do anything else with it. Number 3, the square root of 20. Well, if I split that up, I know 4 is a perfect square that goes into it, and 5 is a perfect square. So the square root of 4 is 2. The square root of 5 I can't do anything with. Nothing else goes into it. That's my final answer. Number 4, the square root of 32. Let's see, the square root of 32, I think 16 goes into 32 twice. Square root of 16 is 4, and I can't do anything with the square root of 2. Number 5, if I multiply these together, that's probably where I want to start. If I'm multiplying roots like this, I would just say combine them and then break them apart later. So 5 times 50 is 250. And I'll have to keep the roots on them because they were both under a root to begin with. Then I have to split this up into perfect squares. Well, I know 25 goes into 250 10 times, so I'll split it into 25 and 10. The square root of 25 is 5. I'll bring down my square root of 10 because there's not a perfect square that goes into 10. And that's my answer. Number 6, square root of 15 times the square root of 3. Let's see, let's combine those first. So 15 times 3 would be 45. And I need a perfect square that goes into 45. I think 9 might be the biggest one. We'll see. 9 goes into 45 5 times, so that looks good. Square root of 9 is 3. Square root of 5 just gets to hang out. Number 9, the square root of 2 times the square root of 2. Let's see, the square root of 2 times the square root of 2, I'm going to combine those first, and I'm going to get the square root of 4. And then I'm going to simplify the square root of 4 then, because it's a perfect square, that's just going to be equal to a regular 2. Now, you wouldn't have to combine them if you remember the rule that two roots, when they're the same exact thing, when you multiply them together, it gives you the regular number. As you can see, I got a regular 2 out of there. That's another rule that you could remember with that. Number 8, 6 root 5 times 3 root 2. My rule for radicals when I'm multiplying is the outsides multiply with the outsides. What I mean is if they're outside of a radical, they'll multiply together. So 6 times 3 is 18. And then the square root of 5 times the square root of 2, two insides being multiplied together, would be 10. So 18 root 10, I think that's my final answer. I can't really do anything else with that 10. It's not a perfect square, and no perfect squares go in, so I'm done. Number 9. My big division rule here is that you can split these up into smaller radicals, like that, and that might make it easier for you to see that the square root of 9 is just 3 because it's a perfect square, and the square root of 64 is also a perfect square, making an 8. My final answer there is 3 over 8. Number 7. On this one, I can't really simplify anything, but I'm just trying to get a radical out of the bottom. So I'm going to multiply and rationalize by going root 3 over root 3. Now we got to remember as we do this that this is not changing the number at all. What I'm multiplying here is basically a 1. That fraction there would divide into make a 1. So there's not really anything changing. It's just changing the way that it looks. So we'll have 7 root 3 on the top, and we'll have root 3 times root 3 on the bottom, which is just a regular 3, and that's the final answer for this one. Here we're going to have to rationalize again. So if I do that, I'll multiply this time by the square root of 2 over the square root of 2. And I'll get 5 times the square root of 2 on the top because those can't be combined. One's outside and one's inside. So don't make that the square root of 10. And then on the bottom there, we've got root 2 times root 2, which is just a regular 2. And we can't simplify anything on that either. That's pretty much done. Okay, number 12. Here's our question. First of all, we're going to look and see if we can, so we're subtracting on these. We've got to look and see if all of our radicals are the same. I like to call that like terms, even though it might not technically be called like terms. But if you're adding or subtracting with variables, it's got to be like terms, so you got to kind of, you can kind of put those together. So on this one, we're going to do 3 root 6 minus 6 root 6 minus 5 root 6. So really what I have to do here is 3 minus 6 minus 5, and that would give me a negative 8, I believe. And then that root 6 is just going to hang on. This is like if I were to ask you the question, what's 3x minus 6x minus 5x? You would tell me it's negative 8x, which is kind of a similar situation for what we've got going on right here. Number 13, we cannot add these together because right now we've got 2 different radicals. That's like me asking you what's x plus y. You can't combine those. Unless we find a perfect square that goes into that 48 and we can simplify it a little bit. So to do that, I'll do 5. I'll separate that 48 into a 16 and a 3 plus 2 and 3, the square root of 3. So then the square root of 16 becomes a 4, so I can cross that out basically and just put a 4 there. Then it becomes 5 times 4, those will be multiplied, and then times root 3. Well, 5 times 4 is 20. That root 3 is just going to have to hang on, plus 2 root 3, and now we have like terms. Now we have 2 root 3. So 20 root 3 plus 2 root 3 is 22 root 3. Number 14, we're subtracting again. We can't subtract unless we have like terms, so let's split up that 27. We'll get a 3, the square root of 9, and the square root of 3, minus 5 times the square root of 3. Square root of 9, again, we can simplify that to a 3, and then what we get is 3 times 3 times root 3, and we get 9 root 3 minus 5 root 3. 9 root 3 minus 5 root 3 is 4 root 3. Okay, next. Looks like on this one it says we're going to rewrite expressions between radical form and exponent form. So we're basically just doing some rewriting on this. So for number 15, basically this is the most basic one we have. We are going to be changing that radical into an exponent, and we just got to remember that our exponent inside the radical is the one that's going on top. Our index right there is going to go on the bottom of our fraction, so we'll have 7 over 3, and we are done. Number 16. A lot of stuff going on here. We just got to remember that the x is the only thing that's being affected by the 12, and the y is the only thing that's being affected by the 8. The 7's exponent is technically a 1. So if I was changing the 7 to have an exponent, I would say 1 over 4, because it's the exponent over the index. Your x would be 12 over 4, and your y would be 8 over 4. And we can simplify a couple of those, so I'm going to do that real quick for you. 7 to the 1/4 power will have to stay. X will now have, well, 12 divided by 4 is 3, so we'll change that to a 3. And then y will have to change that to a 2 because 8 divided by 4 is 2. Number 17. I see that we have an 81 out front. That doesn't mean I'm going to take the square root of it and make it a 9. I have a lot of kids that like to do that. That's not under a square root. If it was under a square root, then yeah, you would have to. but it's not. It's just an 81, so leave it alone. As for everything else, the A has an exponent of a 1. The B is the only thing that's being affected by that 5, which is another mistake that's very common. Everybody thinks everything down here is being taken to the 5th power, but no, just the 5 is, the B is being taken to that 5th power. A is being taken to the 1st power. So for A, I would change that to the 1/4, and for B, I would change that to the 5/4 power. Number 18, y is the only thing with that exponent. So we're going to change it to, well, we'll leave the 4 the same. We'll also leave the x the same, and then we'll make a radical with the y in it, where 5 is our index, and 1 would be our exponent, but I don't need to write that, and I am finished. Number 19, 3 will keep the same. It's not being affected by anything. It's just out front. As for the A and the B, well, this 1/2 is going to go into both. It's going to go to the A and the B because it's outside of the parenthesis, so everything inside the parenthesis gets a piece. So for A, I'll just do the exponents first. So A to the 1/2 power, it's going to get a piece of it. And then we're also going to have B to the 7th power getting taken to the 1/2 power. So that would be like saying 7/2. And then it does want us to put it in a radical, I see. So let's do that. The 3, again, is just going to have to hang out. I can put everything under the same radical here, and I notice that because there's a 2 in my denominator for both, and that is where my index goes. So I'll put a 2 right there. Inside the radical, though, A will be getting taken to the 1st power, which I'm not going to write, and B will be taken to the 7th power, which I will write, and so that is my final answer. Let's see. Looks like that's all I've got on here. So, yeah, the next page was review, I think. 19, yeah, to 20. So that's it. That's the radical test in a nutshell. If you can do all of those problems, if you understand all those, that's great. If not, you're going to have to seek out some help on this stuff. I tried to take it as slow as possible without making this video too long. Let me know if you have any questions.